Hello, and welcome to this introduction to Fleet Debugger. This is a site that allows you to inspect and observe Google Fleet Engine events. This site has four main elements. The first element, and most likely the most important, is the actual map. This is where we visualize polylines, driver, pickup, and drop-off. The next element is a time slider. This is where we'll point each event into the, where time-wise it lies in the whole length of the trip. Next one is we have the events log table. This is basically just a row table with each event. And then finally, we have the fine inspection into request and response of each event. So how do we load data? Well, by default, it comes with 3 data sets. And you can just click any of them to load the data. There's 2 ways to load the data. First one is using cloud logging directly. The second one is downloading, loading a JSON file that you have previously downloaded using Google Cloud Console and cloud logging, or maybe you received this file from a colleague, and then you don't have to, enter the parameters again. So let's specify a file here for the first data set. See, now it populates right away. It populates the map with the trips. It populates the row table, and it populates the fine-grained details. So let's go ahead and load the 3 other data sets as well. Gonna use cloud logging for this. And it received 512 15 events. Let's go here again. Maybe specify a different vehicle. And I can change the time a little bit. It requires either vehicle ID or trip IDs. And ideally, you specify how many results you expect. I wouldn't go too high here, since a very busy driver can generate well over 10,000 events a day. All right, so here we can also see that, hey, there's actually more than 1,000 logs. So this is a good reminder that in case there's more events for you to know. So let's go now into a little bit the more fine-grained details of the site. First, with the data sets, there's a drop-down once you load them. This drop-down allows you to delete the data set. It also allows you to download it. This is especially useful if you, for instance, need to share the data with Google support. So you found an issue with a particular trip, right? And you want to create a log. So you just load the data from cloud logging, and then you click save, and it saves that data, and you can send it to us or to a colleague. The next one is just how to delete. You just right-click. Not right-click, you just click delete after hitting the drop-down. Alrighty, so now let's go look at the first data set. So first of all, you can select any row, and then you long-click it. It focuses the data onto the map. It centers it, and it tells you also using a time slider where in the relation of the trip this event is. In addition, it shows you the details. So now I want to show you a little bit what can we do with it, right? So one of the most important thing is you see a data, you see an event from a driver, you want to know more about the device. So for this, we have both request and response over here. And first we want to know, like, what SDK is this? For this, you go into the request and then the header. And here you now see the platform. It's Android, and it was done via Android 15. The SDK version of the driver SDK is 5. So that's a little bit an older version. But this is always information that is being asked, so you have it right away handy here. Another important aspect is the navigation status. This is already visible here a little bit. Navigation status is important mostly because this tells us, is navigation SDK used? And if navigation SDK used, it would also tell us how the consumer SDK gets the polyline. Because here, for instance, with no guidance, this would mean if the passenger is looking at the app, the route they're getting would be directly from the server side and not from navigation SDK. Another important part in the request is in the vehicle. We have here the device settings, and here we have some important information. For instance, we have the battery percentage. I can click this, and then it actually gets displayed in the table here. So here's the battery percentage. And I can see this battery percentage drops as the usage goes on. It starts at 86 and drops down. And basically, this will help us understand whether the device is going to run into a low power situation, right? Low power situation is not good because it would lower how often it polls the GPS and how accurate this would be, right? It also tells us here is interactive, whether the app is in foreground or not. I think also very important. The rest of the data is here in the last location, but that is much better understood by just looking at the map. So let's do that now. Let's look at the map and, what can we do with the map? So let's zoom in a little bit, and we have here the first pickup, represented currently with green, and the arrows up. This is where the passenger requested to be picked up, and this is where the driver actually said they picked up the passenger. Going to the drop-off, similar here, arrows down. Here is where the passenger requested to be dropped off, and here where he was actually dropped off. Most likely the passenger said, hey, yeah, I'm fine here, just drop me off. But it's good to visually understand that very, very quickly. So next, let's actually play this driver and see what data we get here. So here we can either click left or right, or we can use the play button. For now, I'm just going to use left or right, and I click this button. Fortunately, it has also a table effect that it wants us to go left. But now you can see as my driver here starts moving around. And what information do we get here? One important data we get is the traffic information that the driver actually faced at the time of their trip. We can see here there's a jam, some slowdown, etc., etc. And this can be very important because it influences the driver's behavior in terms of rerouting, etc. Okay, so now let's use the play button just to show you that we have that too. We can have it in real time because a device by default sends an event every 5 seconds. So this setting would represent real-time driver. But we want it a bit faster. We want the time lapse. So let's just do one event every half a second, which is basically 10 times faster than real time. And then we can see this vehicle moving along the path. So the next event I want to show you here is a reroute event where the driver does not follow the path given by navigation SDK. This is happening here. You can see here currently it says, hey, you have to exit here, but it just keeps driving and the reroute event happens. Let's click stop real quick, go up, and we can see that here as an off-route event. We can also visualize off-route events some other way with these buttons here. I'm going to go into those very soon. But yeah, and this basically is the polyline directly from the driver SDK. And the other line that we see, this is basically generated from, so this orange line is generated from the actual raw location from the driver SDK. So as I mentioned, let's go a little bit into those buttons here, which help you with some more troubleshooting. First one, GPS accuracy. Clicking this button generates these little circles here on the map. Each circle represents, first of all, an upload event from the driver SDK at this location. And the size of this bubble represents the accuracy in meters. You can see here, as we were driving on the highway, the accuracy of the GPS was a lot better than when we were close to this big building. This is normal. As there's a built-up event, the GPS accuracy can degrade a little bit. Additionally, if you click that, it automatically adds the GPS accuracy into the table here. Those are these 3, 4, etc. number. These represent the accuracy of the GPS. Next, I want to show you speed. Similar, it generates a bubble for each update event. Here, this large bubble represents a high speed. We also have the speed number right here. You can see here, for instance, this car was traveling at 58 kilometers an hour. Navigation status, because navigation status is again helping us to show when something happens here with navigation status. And you remember, I said, oh, there was an off-route event. It's now visualized here. Dwell location shows you where the vehicle was stationary. This usually represents stoplights or where the driver was not busy because they were waiting for trips. We also have temporal jumps. This is when the driver SDK went offline for a bit. It's also represented here when I jump these events. So let's see whether we can do that real quick. Need to go back a little bit. Yeah, somewhere around here. Here we go. So let me jump forward, and then you will see the red bubble jump a lot. Did you see that? It jumps from here across the missing updates to here. Okay. Next, after temporal events, let's also look at client-server deltas. This is the difference represented in bubble size again, in a dot size, between the time an event is generated on the device and when it is received by the server. So this tells you a little bit about how good the cell reception, the internet connection between on the driver SDK was. The larger the bubble, the more delayed it is. Okay, this pretty much represents everything. Again, I want to show you quickly how to switch between data sets. Because, for instance, if you are here on this event, and then you switch back and forth between these two, it actually remembers where you were. So if I go back to this one, it jumps there, and here it jumps back to the previous event. This helps you when you investigate maybe two vehicles at the same time, or you can load the same data into both and basically, have them saved somewhere else in a different time. I hope this presentation was helpful, and let me know if there's any improvements you would like to see, and we can look at doing them. Again, you can find this on GitHub under Fleet Debugger. Thank you so much, and have a good day.